So today, we're going to be talking about the length of segments when two chords intersect in a circle. Now I'm going to put this in as friendly language as humanly possible, as student-friendly language. I'm going to be technical, but I'm not going to be like we're all sitting in MIT trying to do rocket science. So our first objective is our only objective of the day. By the time you finish this lesson, you will be able to do the following. I can find the length of segments when two chords intersect inside a circle. All right, copy that down. I'm going to give you an example. I'm going to show you pictures. I'm going to give you a couple problems, and that'll be the end of our day. It's going to go by fast. Right now, you have no clue what this is even saying hardly. So I'm going to break this down extremely thoroughly for you. So to explain to you what Dagwan, let me show you in a picture. I got a circle. Okay, I tried to draw a circle anyway. Now, a chord is nothing more than just a line segment, but what's special about the line segment is the endpoint, both endpoints, are on the circle, so that's a chord. That's a chord. Maybe we can call this point A and call this point B. And this is a chord. We call that point C and call that point D. And it's a chord because the endpoints lie on the circle. That's a chord AB because the endpoints lie on the circle. It's a chord. The point where they intersect, let's just give it a name. Let's call it point, I don't know, E. And there we go. So the main concept, well, before I give you the main concept, I have a question for you. This is something I want you to keep in mind. So here's the question. You got to look at the diagram. I'm going to ask you a question. How many pieces are each chord broken up into due to the intersection? How many pieces, listen to the question. How many segments is each chord broken up into? Okay, you have to listen to the question. Let me finish the question. I want you to process. Okay, you're answering and I didn't. You have to listen. I'm begging you. You got two chords, they intersect. My question is, how many segments is each chord divided into? Okay, you didn't think about it. Stop calling out. I need you to think about it. How can you possibly be thinking about it if you're calling out numbers like it's The Price is Right? That just says you don't care and you're trying to turn this into a comedy show. And I'm not appreciating that, I promise you. It is 2. For what reason did you give me 2? Anybody else? You got to, now I need to know if you got the logic, or this whole presentation makes no sense. You got 2 chords that intersect each other in a circle. They intersect at point E. Now listen to my question. My question is, how many segments was each chord divided into? If you look at chord AB, which goes from point A to point B, because of the intersection with chord CD at point E, how many segments was AB chopped up into? Yeah, hopefully you'll say 2. One segment was from A to E, and the other part of the segment was from E to B. So that's 2 segments. Each chord was chopped up into 2 segments. Raise your hand if that made any sense. Now here's concept time. Please listen. Please listen. I'm going to say it. I'm asking you not to talk. Don't ask a question. Don't speak. I want you to watch, listen, focus. Don't get up and sharpen your pencil. Watch, listen, and focus. Have a seat. Sir, are you talking? This is concept time. Pay close attention. The concept is, when 2 chords intersect in a circle, each chord is chopped up into 2 segments. But here is the concept. This is what the next 4 or 5 or 6 problems are based on. EOC questions based on. When the 2 chords intersect inside the circle, the product of their segments are equal to each other. The product of their segments equal each other. I'll show you by way of an example, and then I'll put it in words. But since these 2 chords intersect inside the circle, the product of their segment lengths equal each other. Like, for example, supposing I told you that the segment length from C to E was 3 units. And supposing I told you that the segment length from B to E was 2 units. And then supposing I told you the segment length from E to A was 10 units. No, make it 6. If I told you from E to A was 6, and then eventually I'm going to ask you to find the segment length from E to D. And I'll just call that X. And I would say to you, find X, where X represents the distance from point E to point T. That is the question. It's based on the following concept. And I'm trying to put this in student-friendly language. When 2 chords intersect in a circle, comma, The products of their segments are equal. Write that down. Then we're going to land this plane, and I think you will have the concept. We'll do a couple of problems and practice, and our day will be done. Everybody in here, as long as you're awake, taking notes, participating, not sleeping, talking, laughing, playing, or on your phone, even for a second, you get full credit. So, based upon the concept, when two chords intersect in a circle, the product of their segments are equal. I'm going to demonstrate what that means. But I want to make sure everyone's copied this first. Okay, put my ruler back down because that's disruptive. On the counter because that's not yours, it's mine. Thank you. And here it goes. The product of their segments are equal. The product of their segments are equal. The product of their segments are equal. That means that if you take the product of these two segments, notice lines, the chord AB was chopped up into two lengths. The length from A to E, which we said was 6. The length from E to B, which we said was 2. If you take the product of their segments, they're equal. So the product of these two segments, which would be 6 times 2, that's the product of the segments. What's the product of these two segments of chord CD? And it'll be like this number times this number. This is one segment, that's the other segment that it was chopped up into. So 3 times x is the product of the two segments. So the product of the product of the segments of CD equals the product of the two segments of AB. In other words, when you multiply 2 times 6, that better be the same thing as 3 times x. So what does that force x to be? 4. For the reason that 2 times 6 is what? 12. So it's like saying 3 times what is going to equal 2 times 6? And it's going to be 4. Because 2 times 6 is 12, then 3 times what number is going to be 12? Because they have to be equal. And if you didn't know, you could say 3 times x equals 12. Divide by 3. Divide by 3. X equals 4. And you could tell if that's true. Because 2 times 6 is 12. What's 3 times 4? 12. Due to the concept of the day, when two chords intersect in a circle, the product of their segments are equal. So you got to be able to create an equation and solve. You may have to plug in. That's the main concept upon which we build. Finish writing it down because I have a question for you. We go to this paper. Put your name. The date. Period 6. You got to put your name, date, and period on everything. Okay. So, without me belaboring the point, let's take a look at some actual questions and then be done with it. For example, using this concept of intersecting chords in a circle, your goal is to create the equation based on the concept. You're going to have to solve. And you may have to, what you guys call, plug in. They might be asking you for a segment, and not just to find x, but they might be saying find the length of the segment, and you might have to use the x as an input value. Okay, so like I said, without belaboring this, let's give you a chance to work with me and solve for x. Notice in this circle you have two chords that intersect right there. And the question is, how can I apply the concept of the day to create an equation? Well, the concept of the day, when two chords intersect in a circle, the product of their segments are equal. So, this is what I mean by their segments. Like this chord was broken up into 27, a length of 27, and a length of x. This chord was broken up into a length of 9 and a length of 21. So those products equal each other. Let's take the product of these two lengths for this chord. And what is the product of those two lengths? Well, if this is 27 and that's x, what does product mean? Multiply. So what are you going to get for this product? The product of the two lengths. What does product mean? So what is the product of the two lengths of this chord right here? Well, if that's an x, how do you know it's 54? Don't you have to multiply them? What do you get when you multiply them? Well, that segment's 27 and that's x. What do you get when you multiply 27 and x? Okay, there you go. That's the first product. The product of the two segments. 27 times x. The product of those two segments, they have got to be equal to the product of the segments of the other chord. These two segments. So if that's 9 and that's 21, what's the product of those two chords? Let's actually write it down. 9 times what? Is 21. The product of these two. Now, I'm showing this to you because what I'm going to tell you is you have to show the equation. You've got to demonstrate how you arrived at your answer. And the first step is to create the equation. So 27 is this length. X is that length. We multiply them. That's the one product. 9 is this length. 21 is this length. We multiply them to get the product. The products of their segments always equal each other. That is the creation of the equation. Then to solve, I guess you can use a calculator and go multiply 9 times 21. Thank you for that. Then solving equations, just divide both sides by what? So x equals, and they're only asking you to find x. So basically what it means is 9 times 21 has got to equal 27 times 7. That one's done. Based on the concept that the product of the segments equals each other. They equal each other. So that's the concept that we base the equation. We solve the equation. And we didn't have a plug-in because they're only asking for x. We found x. That's done. So the only difference is now, if it could get complex, but the difficulty level doesn't really change. The concept stays the same. The only thing is, if you ever have like 3x minus 5 like you do here, That's a quantity. When you multiply, you're going to have to put a parenthesis around that. So like if I set up the equation, again, the product of the segments, like 8 times 15, equals the 3x minus 5 times the 12. Well, I always write the one with the x in it first, and I put the single number in front. So I'll put 12. And what am I going to multiply 12 by? Yeah, and we say parentheses 3x minus 5 close parentheses. Why the parentheses? Because that ensures us to multiply 12 times 3 and 12 times the negative 5. But we have to finish the equation before we get ahead of ourselves. The product of these two segments equals the product of the other two segments, which is going to be what? 15 times 8 is correct. I created the equation. Yay. I created the equation based on the concept that the product of these segments equal each other. Now, if you could kindly multiply through by the 12 across the division, 12 times 3, so that's 36x, minus 12 times 5, and then 15 times 8, which is, I'm sorry, what is it? Bless you. Now, when you solve this one, you kids, so we're going to add 60 here, add the 60 there, yay, cancels, 36x equals, okay, 180, gotcha, thank you, bless you, 36, divide by 36, so x equals, now I want to put a box around and say I'm done, yay, but if you read carefully it says FD. Nothing above the FD, so it's the distance from F to D. Now here's the second part. The distance from F to D is the segment addition postulate. You add this segment plus this segment and you'll find FD. I guess what I'm trying to say is the distance from F to D is this segment, which is 3x minus 5, plus this segment, which is what? Did that make any sense? From F to D, it's this piece plus this piece. That's what I put there. The distance from F all the way to D is the addition of this segment, 3x minus 5, plus this segment, which is 12. And I wrote it like that. So from F to D is just this piece, 3x minus 5, plus this piece, 12. And then if you want to simplify that, you can. Or you could just take our plug-in value and substitute it where x is. So the distance from F to D is just going to be 3 times 5 minus 5 plus 12. And just use the calculator, complete calculator work. Just go 3 times 5 minus 5 plus 12, which is, it is exactly what you said. That's exactly. I wouldn't do that now. Now, the only other thing I want you to do for now, since you did so awesome, is to give you a challenge. And you will be rewarded very nicely. Number 3 and number 4. I'm going to give you some time. I'm going to interrupt you and then go over them. And that might just end our day on a good note. We'll just time you and give you like 6 minutes. Start with number 3. On your mark, get set, go. Right. Let me see the back of your pass. Yeah, go. Thank you. I'm going to pause this. Also, if you need a calculator, make sure you got one. So, what I asked you to do was to try to solve this, but honestly, if you just put an answer and you don't show how you got it, it's not really valid work. So, based on the concept, the product of the segments are equal to each other. And for example, it doesn't matter which segment you start with. If you want to start with this chord, the product of these two segments, think about that. What would the product of those two segments look like? Multiply, multiply. How would that look? I might start with just the number and multiply that by the other part of the segment, the other part of the same chord, which is 7x plus 2. Isn't that the product of those two chords? I mean, those two pieces of that same chord? That's got to be equal to the product of the two segments of the other chord. Which one do you think I would write first, the 6x plus 3 or the 20? I'd probably do the 20. I use a parenthesis before I put 6x plus 3. That ensures that I'll multiply straight through both values. When I multiply this, I distribute to both. So not only do I say 18 times 7, what did you say it was? 1, see that? I appreciate. Plus 36. 20 times 6, which is, okay, all right. Now, if you don't believe me about those points, look at your grade. I already put the grades in for you. But don't look at them now, because that'll turn it back to a 0. Listen. Did anybody do that right? Minus 120, even if you made a mistake, if you learn from it, that's a blessing. Minus 120x. 126x minus 120x is just, and that equals a 60. What do we subtract from both sides? Thank you for that. Cancels. Then that gives us 6x equals, what's that going to be, 24? And so what does x equal? That's done because all they're asking for is x. Okay. Now, work on that last one, please. So finally, we come to the last one of this concept, and it's the same thing. The product of their segments equal each other. Now, I was walking back there and I saw Justin. He wrote it like this. I think, I just saw it briefly. I might be wrong. But what I think I saw him do, and it wasn't wrong, but he said, okay, I'll multiply. He knew to multiply this segment times the rest of the same segment, the same chord. I think he might have done something like this. Like when he multiplied these two. I think he did it this way. He went open parentheses, then he went x plus 11 and multiplied that by 42. I'm not sure if that's how he wrote it. I think so. Then he put equals. Then he took this segment, which was 3x plus 1, and multiplied that by 30. And he knew enough to put the parentheses around there, and he knew enough to multiply, and that's perfectly 100% acceptable. But when he distributes, he's going to go backwards. multiply this, multiply that. So what's 42 times x? And what's 42 times 11? What is it?
462.
Thank you. Even if you put 462 plus 42x, he's still correct. Then if he multiplies this way, that'll be a 30. When he multiplies this way, that'll be 90x. 30 times 1, which is... You'll still get the same answer. You'll still get the right answer. You'll also get a 0 for playing with my ruler, but that's okay. Now, question about that? Oh, yeah. You mean if you put 90x plus 30 equals 42x plus 462, that's fine.
No, you mean like swap the whole problem. That's what I just said.
As long as those two numbers are together, even if it's 462 plus 42x, that's perfectly okay. Now, as far as I'm concerned, I don't like dealing with the negatives, but I would probably sit there and go minus 42x here. I'm sorry. What's the question? Okay. See, when you're sincere and you're asking a question, I acknowledge you with sincerity. So that cancels. We're left with 462. And then 90 x's take away 42 x's. Oh, thank you for that. And then don't forget plus 30. Minus the 30. Minus the 30. That cancels. And then that's going to give you... In the final steps of this equation, divide by 48. Divide by 48. Thank you for the calculator. We get x equals... Is it 9? Yeah. 9 times 9. And then some people would say, oh, I'm done. This is so EOC-ish, it's not even funny because they're not telling you just to find x. You got to plug in to find US. Hold on a second. How do you get 58? But wait now. Wait. Remember, US equals 3x plus 1 plus 30. Okay, and then you put the 9 there. 3 times 9 plus 1 plus 30. And what did you say it was? Did everybody get 58? Okay, I think it's 58. Okay, pause. Raise your hand if you learned a little something about this today, because it's not going to get harder. It will not be harder. That's just a fact. That's what you got to know. So thank you. I think you did a marvelous job. I'm very proud of you.